Lesson 10.1, Lines, Rays, and Angles. We're going to talk about a lot of information in this video, so I would listen to the little penguin and take notes. We can draw points, lines, line segments, rays, and angles if we understand their definitions. Point, it's an exact location in space. It's like a dot. Like this. Line, it continues in both directions without end. It goes on for infinity, with an arrowhead on each end. Line segment, that's part of a line that is between 2 points. So here we have a line, if you look at the dotted ends here, and in between this point and this point, that's a line segment. An array is part of a line that has only one endpoint and continues without end forever and ever in the other direction, shown by an arrowhead. So this is a ray. It's like the rays of a sun coming from the sun going out into space. And it begins at the endpoint. Angle. It's formed by 2 rays. Here we have a ray, and here we have a ray, or 2 line segments. Here we have a line segment, and here we have a line segment. And they share the same endpoint called a vertex. So the angle right here is inside of 2 rays. This angle is inside of 2 line segments. So in this chart, we've got the name of the term, how to draw it, how to read it, and how to write it. For a point, we make a dot like this. We can label it with a capital letter. We read it as point A, we write point A. For a line, we draw it like this, an arrow on each side, and we can see there's point S and point T on this line. We can call this line, labeled with capital letters, line ST, or TS. We can go in the other direction. The way we would write it is the capital letters for the points, like ST. We would draw a little line on top of it with an arrowhead on each end. Or, since it's going in both directions, and we can read it as TS, we can write it as TS with the little line on top with arrows on each side. Now, you might see it labeled with one script letter like this. This is the script letter L. And it could be an M, N, P, R. As long as it's a script letter, you'll see one letter like this. And we would just read this as line L, and you would write line L with that script letter. You're going to see that as you get older. For a line segment, or sometimes they're just called segments, we would draw it like this. It's got an endpoint here and an endpoint here, and it's labeled with capital letters, and we can read this from left to right or right to left. We can read it as line segment FG or line segment GF. And we would write it with the name of the points, FG, with just a plain bar over the top, no arrowheads. That's for lines, not line segments. We can also write it as GF going the other direction and just put a bar over the top. A ray, we label it with capital letters, just like we did with the line and line segment and point, and it starts with this endpoint, and it's going through the point K. We read it as ray JK, and we would write it with the capital letters JK, and just like it has one arrowhead going in one direction, we would write the capital letters JK with an arrow pointing to the right. So even if the ray is pointing to the left, we would still write it with the arrowhead pointing to the right like this, okay? For an angle, the middle letter is always the vertex, we would draw it like this. Here it's drawn with 2 line segments. Here it's drawn with 2 rays. And we would read this as angle ABC, or we could go the other direction and say angle CBA. And we would write it with this little symbol, which stands for angle, angle ABC or angle CBA. And see how the middle letter is the vertex? Sometimes they're just labeled with the vertex, and we would read this as angle B. We would write it as the angle symbol and B. Now, we have to be careful. Don't confuse this angle symbol for a less than sign. For the angle symbol, one line is slanted and the other one is flat, going straight across horizontally. For the less than sign, they're both slanted. See that? The angle symbol has a flat bottom and then it comes up on a slant. Angles are classified, that means they're grouped, by the size of their opening between the rays. This is a right angle. We know because there's a little box here that tells us it's a right angle. And right angles form a square corner. Straight angles form lines. Look, the vertex is right in the center. That's a straight angle. Acute angles are less than a right angle. They're more closed than a right angle. You can remember acute angles because they're cute and small. Acute, get it? Obtuse angles are greater than a right angle, and they're less than a straight angle. See, they're greater than an acute angle also. We can classify an angle by comparing it to a right angle. We can use the corner of a card if we know that it's an uncut, unripped card. We could also fold a piece of paper in half twice to make an accurate right angle. So this piece of paper was folded in half twice. If you look at it opened up, it was folded in half like this, real nice, so the edges lined up. Then it was folded in half again, real nice, so this lined up, and we made a right angle. And the reason we fold it in half twice is you could fold it in half once if you've got a new piece of paper, but if you've got a piece of paper that's not perfect, you fold it in half, then you fold it in half again, and look, we've got a nice right angle, and we can match it to angles to see if they're right angles. See, this one's a right angle. See how it lines up? So if the angle is less than this corner, it's an acute angle. And if it's greater than this corner on our paper, it's obtuse. We need to label each angle as right, straight, acute, or obtuse. And we can use our corner. What we do is we lay our corner like this on the bottom line, and we see if this line matches it. And look, it doesn't. It's smaller than a right angle. And which angle is smaller than a right angle? It would be an acute angle. We know that this angle is greater than a right angle. If we put our paper like this, it's a lot greater than a right angle. We can also see that it's going straight, isn't it? So do you know which angle this one is? It's a straight angle. Now we can find out about this one. We take our paper with the right angle and we lay it on here, like this, up against this ray. And look, it's greater. This line is sticking way out. If it were a right angle, it would be about right there, so that if we lined this up, see how it would line up? But this one is greater. This is an obtuse angle. We can use our paper to line up this last one. Look, both rays match the corner perfectly. That must be a right angle. So remember, an acute angle is less than a right angle. They're cute and small. A straight angle makes a line, a straight line. An obtuse angle, well, that's greater than a right angle, and it's less than a straight angle. And a right angle makes a corner. It makes a square corner. We can name lines and line segments in two ways, starting with either point, because lines extend without end in both directions, so we can name either point first. We can say this is line AB or line BA. The arrows show that they go forever in that direction. And line segments have two endpoints, so we can name either endpoint first. Remember, when we write for a line segment, we write the capital letters for the points with just a bar over the top. So this is line segment AB or line segment BA. A ray can contain a line segment. Here we have ray AB, and we start at the endpoint when we label it. Remember, it's not like a line segment or a line that we can start at either end. We have to name the ray by its endpoint first. And if we look in between the endpoint A and this point B, we have a line segment. A line can contain a line segment. Here we have line XY, and in between the points X and the Y, we have a line segment. Whenever we have a part of a line in between 2 points, that's a line segment. We need to use the figure to name these parts. We need to name a line segment. Well, I see several line segments here. We can just name any one of them. How about line segment AD? That would be right here. We write the capital letters AD with a bar over the top for line segment. We need to find an acute angle. Do you see an acute angle? Remember, acute angles are cute and small. How about angle D? Right here. We can call this angle ADC, and then the D would be the vertex, wouldn't it? The vertex is always the middle letter. How about a right angle? Do you see something that looks like a right angle? Now, many times in figures, the right angle will have that little box in the corner, but I don't see one. We can use the corner of our paper to find one. Look. Angle ABC is a right angle, and angle DAB, starting with the D down here, going to the vertex A to B. Look, that's also a right angle. So we could use either one of those. And we can even call it angle CBA and go the other direction as long as the vertex is in the middle. We need to find an obtuse angle. Remember, obtuse angles are greater than right angles. And they're greater than acute angles. Do you see an angle that looks bigger than a right angle or an acute angle? Would this be right here with the vertex C? And we can call it angle BCD, or we can call it angle DCB and go the other direction. We can use either one. As long as the vertex is the middle letter, we can go either direction. We need to draw and label an example of each figure. So we need to draw a straight angle ABC. Remember, that middle letter is the vertex. A straight angle looks just like a straight line, doesn't it? It'll have a center point where the vertex is. And we need to put points A and C on the line. So we have straight angle A, B, C. Now we need to make an obtuse angle JKL. So we know the vertex is going to be the middle letter K, and if it's obtuse, it's going to be greater than a right angle or an acute angle, won't it? We draw it greater than a right angle and an acute angle. We make the middle letter the vertex, and we draw points J and L somewhere on the rays. Do you know what this is? It's got an arrow pointing in only one direction. If you said ray EF, you're right. We need to draw a ray and label it EF. We know a ray starts with an endpoint and continues in one direction. Do you remember the label for the endpoint? Is that going to be the E or the F? If you said E, you're right. The endpoint where the ray starts is the first letter. That's E. And we can draw point F anywhere on the ray that we want. So now we have a straight angle ABC, an obtuse angle JKL, and a ray EF. We need to use this figure to name these parts. We need to name a right angle. That's probably the easiest one. Do you see a right angle? Look, we have our little box telling us that this is a right angle. We know that M must be the vertex. We can call this angle CMN. The letter of the vertex is in the middle. We also could have called it angle NMC if we wanted to, and it would have been correct. Can we name a line segment? Oh, there are a lot of line segments in this figure. We could choose any one of them. We have a line segment AB right here. We have a line segment DB. We have a line segment BM and LM and MC and MN and BF. There's lots of line segments here. We could choose any one of them. Let's choose AB. We write the capital letters AB and put the bar over the top for line segment. We need to name an acute angle. Remember, acute angles are acute and little. They're smaller, they're less than a right angle. Do you see an acute angle? This one doesn't look very big. It's not a right angle. It looks smaller. See right here? And look, the one across from it also looks like it's less than a right angle. So we could choose this one or this one. We can make angle ABD, and the B would be the vertex. So we write the B as the middle letter. Now we need to name an obtuse angle. Remember, obtuse angles are greater than right angles and they're less than straight angles. Do you see an angle that appears to be greater than a right angle? How about this angle right here, or the one across from it, this one right here? We could choose any one of those. We can choose angle DBM, and the B would be the vertex. We could also call it angle DBC, and we ignore this point and say that that's the angle. We could even do that. Can you follow that with your eyes? Angle DBC. Now we need to name a ray. Oh, I see a lot of rays. Do you see an endpoint with an arrow pointing in a direction? How about ray BA right here, starting at this as the endpoint and continuing on this way? We could even say BD is a ray, or ML is array, or MC is array, or MN is array, or BF is array. There's a lot of rays in this figure. We could choose any one of them. How about ray MN? We write the capital letters MN and an arrow pointing to the right for ray MN. We need to list the angles in this figure. So right away you can see here's an angle, and here's an angle, but there's actually more angles than that. We can list angle ABD, where B is the vertex. We can list angle DBE with B as the vertex. We can list angle EBC with B as a vertex. Do you see other angles? We actually have angle ABE. If we ignore this ray, we have an angle ABE here with B as a vertex. Now can you find another one since we did ABE? What about angle DBC? And we ignore this ray right here. We have angle DBC with B as a vertex. And there's one last angle hiding here. Do you see it? It's the straight angle ABC with B as the vertex. So even though we didn't notice them right away, there were more angles here, weren't there? We can just ignore this ray and find that angle. We can ignore this ray and find that angle. And we have to remember there's a straight angle here. So remember as you're writing these, that if it's a line, it's going to have the capital letters for the points and an arrow on each side. If it's a line segment, it's just going to have the capital letters for the points and a bar on top. And if it's a ray, it's going to start with the endpoint, like this J, and it's going to have an arrow going off to the right side. Even if the ray is pointing in another direction, or up or down or left, we write it with a little arrow pointing to the right. Our next lesson, 10.2, we're going to classify triangles by angles that they have inside. Those are called interior angles, inside angles. I hope you're having a really nice day. Keep trying hard, and I'll see you next time. Bye.